And we're going to talk about intercepts and then look at a little bit more detail with functions when we have special cases. And we're finding the domain. All right, so we start up here at the top. Looking at finding the intercepts of these functions. So we first got to talk about like what's an intercept. So anybody, what is an intercept of a function? Say that again.
Where the line crosses the graph.
Where it crosses the graph. Yep. So let's say I'll just sketch a graph. You don't have to draw this. The y-axis would be here. The x-axis would be going left to right. How many x-intercepts does this graph have?
3.
It's got 3. They're the points where the graph crosses which axis? The x-axis. That's an x-intercept. How many y-intercepts do we have? 1. That's the point where the graph crosses the y-axis. Okay, so I like to abbreviate it like this. Like I say, I'm lazy sometimes. I'll just say y-int, and then you'll see.
They're working on the fire alarm system. If it goes off again, please wait for an announcement. Thank you.
We got x-intercepts as well. Okay, so these are pretty easy to find when you're looking at a graph. Take a little bit more work when we actually have a function and we want to find the x-intercepts. All right, questions on what an intercept is? Everybody understand? All right, so when we're given a function defined by y or f of x, means the same thing. The x-intercepts are, the x-intercepts, make sure I don't get them backwards. The x-intercepts are the real solutions that results in the equation equaling 0. So if I go back to my little image I drew, what that's basically saying is, on this x-axis, what's the value of y across this line? 0. So when we have an x-intercept, y equals 0. For the y-intercept on this line, what's the value of x? 0. So for our y-intercepts, the x-coordinate will be 0. That's all this is saying. And we basically use that idea to find the intercepts when we have equations. So to find the y-intercept, we're basically going to evaluate our function for when x is 0, and it'll give us the y-intercept. Let's look at this in action. So I tried to kind of write over this because it just didn't come out well on the printer at all, but I'll just rewrite it. This is f of x equals x squared minus 4. All right, so let's first find the x-intercept. So I'll start off with my function. And what we do is we take the equation part of it and we set it equal to 0 to find the x-intercept. And then I'll just make a little note of what we're about to do. We're going to set equal to 0. That's what that's telling us to do. So this x squared minus 4 is my equation. I'm going to set it equal to 0 and solve. Okay, what we got here? What would I do to solve?
You would add 4 to both sides.
Sounds good. X squared equals positive 4?
Yes.
And then what?
You would take the square root of both sides.
Fantastic. And when I take the square root of both sides, I have to use what?
Plus or minus.
Plus or minus? Because my correct answer could have been negative or positive since I'm going to square it. Right, what's square root of 4?
2.
So x can be plus or minus 2 or positive or negative 2. I'll write it like this just so we understand what we're looking at. All right, so I have 2 x-intercepts for this one. So I'll say x-intercepts at negative 2, 0 and 2, 0. Because on the x-intercept, the y-coordinate is 0. Right? Does that make sense?
Would you do the same thing if you were trying to find the y?
Not quite. Because for the y-intercept, x is 0. So we got to let x be 0. So we just kind of swap some things around. And that's what we're about to find right now. All right, so let's do the y-intercept. For the y-intercept, we're going to let x equal 0. So really, you can just put 0 in place of the x's you see when we do this, or you can do it like we've been doing when you're evaluating a function. So I'll write it just so we kind of understand the lingo. We're going to evaluate this function for f of 0. So we're going to let x equal 0. So I will replace the x squared to be 0 squared, and then I will subtract 4 from it. What's 0 squared?
0.
So my answer will come out to be just -4, right? So when x is 0, y is -4. So at this point is where I have my y-intercept. Right, and just as we finish getting that, I'm gonna graph this and let's see if this matches up with what we thought it should. So if you haven't used one of these before, we'll do a little bit more with it, but you go to y equals, I can type in this function, x squared minus 4, and I'll graph it. So bright, isn't it? All right. See, can we see that without the lights? No. All right, so what were my two x-intercepts?
-2.
Does that match these 2 points right here?
Yes.
-2, +2. What was my y-intercept? -4. Does that match right here? So we found it without looking at the graph, but yeah, everything lines up here.
Does it matter what order it's in?
It doesn't matter. Doesn't matter. All right, let's do this again. So we want to find the intercepts, new function. Let's first find the x-intercept again. What do I do to find the x-intercept? What did we do last time? Set it equal to 0, or we let y equal 0. So we set equal to 0. I want you guys to do that, and let's see if we can solve this. How many terms do we see here?
3.
3, that's a trinomial. How do we solve a trinomial? We did this last class. We did the 2 parentheses. But we got to do this. It's the opposite of 4. Factor. We got to factor it. All right, let's see if we can do that. We did do this in the last section, right? We didn't talk about factoring? We didn't talk about factoring? Okay, we might need to go on a little adventure. Let's see, can anybody come up with how to factor this? Yeah, I don't know what I'm talking
I
about.
had Mr. Shivers last year, so
Yeah.
he didn't teach.
Okay,
+1 times x +2.
yeah, good job. 1 and 2 plus and plus, and then we would set each factor equal to 0. Do I need to talk about this, guys?
Yes, sir.
All right, let's talk about this. All right. All right, so we solved that last one like this, and the method we did was, I think it's called like the square root method, because we were able to isolate the x, and then we could just take the square root of both sides. So that's like a method of solving that we did in the first time. Everybody seemed like they felt pretty good about that. Another one is when you get a, like it's to the second power and you have three terms. Let me see, I'm making these up, I gotta make sure they work. Let's do this. And we wanna solve. So 1, 2, 3, we call it a trinomial, and it's to the second degree. So the method we use to do this is what we call factoring. All right, and we basically do the opposite of full. And we want to see if we kind of unfold it, maybe it's a word that makes more sense. If we unfold this, what would it be? So we'd be looking for some terms to put into this spot. So like before, what we were doing was maybe if we had like x plus 2 squared. And then I said, oh, you got 2 of those. And then we do first times first, outer times outer, inner times inner, last times last. And then we would combine our like terms, which would take us here. This is what we've been kind of working through. So with these, we're starting here, and we want to go back to here because this is how we solve. So we're basically going backwards. Does that plan kind of make sense? We're starting with this. We want to end up with, not even that because we might not be able to square it. We want to end up with this because we can get different numbers there in different times. Okay, so kind of the trick is, I know when I do last times last, the two numbers that I multiply together have to be that last number. There's no way to get around that. And then I got to make it work to where when I add the two middle terms together, they equal this number. So when I split them up like I did here, all of that needs to be able to line up. So the trick for this is you look at the last number, and we're just going to make a list of the factors that can come out to equal 6 when I multiply two numbers together. Give me two numbers that I can multiply together to give me a result of 6. 3 times 2. Are there any others? 6 and 1. And since it's multiplication, we can change the order. You can do that. That doesn't matter. But these are my pairs. The pair that I'm looking for is always the middle number. When I add or subtract them, I get the middle number. Which pair would give me a result of 5 if I add or subtract?
3, 1.
So you're right. Both of them could. Both of them could. So let's try both of them, and then let's see what happens. So when I do first times first, I'll need x times x. There's nothing else I can multiply together to give me x squared. Am I okay with that? And then we're saying my two options are 3 and 2, 1 and 6. Because when I do last times last, they both give me 6. One of these should work for us. Okay? So the simple fact that when I multiply these together, I get a positive number. What would my combination have to be when I multiply to get a positive number? Well, I would have to have two positive numbers that I multiply, right? What could the other option be? 2 negatives. So if I did 2 positives here, what's 1 plus 6? That's not going to work. If I did, because I need 5, right? If I did 2 negatives, what's negative 1 minus 6? That's not going to work either, is it? So the 1 and 6 don't work. Let me go to the 2, 3, and 2. Will that work?
Yes.
If I make both of the signs what?
Negative? Positive?
Positive. Because I want this number to be positive. So just to show you, first times first, what's outer times outer?
3x. 2x.
Yep, 2x. Inner times inner,
2x.
last times last. 2 plus 5, 2 plus 3, 5x. Okay, so I got back with what I started. So we just factored this. Let's do another one. Any questions yet? Let's do another. All right. So what will I need in these first positions to get me back to x squared? X times x. So the only way this would probably change is if you had something like a 2 or a number in front. Then one of these would have to be 2x, because I would need 2x times x to give me x squared. Most of these that you see, for the most part, won't have a number in front, so you'll always be able to start with x times x. Okay? So I need to write factors of what number? 12. Give them to me. 3 times, 2 times, is that all of them? 12 times 1. I need a combination that's going to give me 7. 3 and 4? Yep, both need to be positive. 3 plus 4 is 7, perfect. 3 times 4 is positive 12, perfect. That's it. Got it? All right. And when I see these 3 terms and second to power, this is automatically where my mind goes to solve. Let me do these 2 parentheses. Let me see if I can factor. Okay, first time first, x and x. Factors of what number? What are they? 4 and 10 and 1 and 20? Any others? Which pair do I need? 4 and 5? Because that can give me a combination of this middle number 9. 4 and 5. What should the signs be? One of them or both of them? You're right, because it's negative. At least one of these need to be negative. But what happens when I multiply negative and negative? It becomes positive, which is what I wanted. If I did a negative 4 times a positive 5, I won't get a positive 20. So the simple fact, whenever you have positive, the signs have to be the same. And since this number is negative, the result needs to be negative. So if I forward this outer times outer, I would get negative 5x. Inner times inner, I would get negative 4x. Together, they would give me negative 9x. So when these signs change, you will have to kind of think about your signs when you factor a little bit. Does that make sense? All right, now let's do one where you just got a little bit more decisions to make and we'll move along. So let's see. Let's do this. Right. In the first position, what do I need? X and X. I look for factors of what number? Yep, you can do negative 30. I just do 30. And when I put it in, then I think about my signs. But you can do negative 30. That will work. Give me some.
6 and 5.
Okay. 3, 10. I heard one more.
1 and 30.
1 and 30. 2 and 15. So you might not write all these down. If you get started and you're just like figuring these out, you might write these down. A lot of you just be able to kind of think, oh yeah, these are the 2 I need. I think we got them all. And just understand, I mean, you can say negative 6 times positive 5 is negative 30. You can switch it and say positive 6, negative 5. You can do that if you have to do that to think about it, but just understand one of these numbers is going to need to be negative, right? Because that's the only way I'll get a negative when I multiply. Any pairs jump out at you guys?
6 and 5.
Why you choose 6 and 5?
Because negative 5 plus 6 is, wait, hold up, negative 5 plus 6 is 1.
Yeah, positive 1. That's perfect. This is the pair I would use. So at this point, I know the signs are going to be the same. I'm thinking which one of these pairs is 1 away. And then I say, oh, 6 and 5. Those 2 are 1 away. Let me write them. And then let me think about my signs. The bigger number needs to be what? Positive to get a positive result. So then I say, let me see what happens if I do it like this. Do I get negative 30 for last times last? Yeah.
Yes.
6 minus 5, is that positive 1?
Yes.
Yeah, this is the pair I need. All right? And some people, like, there's nothing wrong. Use a pencil, you might do this, you might check it, say, oh, they give me, oh, let me change them and see what happens. Or let me change these numbers. Let me change these numbers and see what happens. So I wrote it backwards, but will this work?
Yes.
Yeah, because it's multiplication. The order doesn't matter. Okay? You guys feel okay about factoring? So I need to do like a harder one, or you feel, got the gist? All right. All right, so why do we have to factor? Well, now we take each factor and we set it equal to 0. So this first factor, which is x plus 1, you can now set that equal to 0. And this will give you one of your x-intercepts. What would I do to get it equal to 0?
Subtract it from both sides.
Subtract it from both sides, so x equals negative 1. That's one of my x-intercepts. Let me get the next factor and I'll set that equal to 0. Subtract 2 from both sides and I get x equals negative 2. So these are my two x-intercepts. So we got x-intercepts at, and you can just write x equals negative 1, x equals negative 2. I'll put them as ordered pair because for whatever reason a lot of people don't make that connection that this is an actual point on the graph. So I'm going to write it like this. So both of these are answers in a way. But I do want everybody to just understand this is a point on your graph. And I like the y-intercepts because they're pretty straightforward. I mean, if we just put 0 in this function, what's my result going to be? Just 2, yeah, just 2. So that's my y-intercept. F of 0, I got 0 squared plus 3 times 0 plus 2. And let me not get ahead of myself. We were finding the y-intercept. So we let x equal 0, which is what I did right here. 0 plus 0 plus 2 equals 2. Y-intercept at 0, 2. If I zoom in and let you see, we had x-intercepts at negative 2 and negative 1. That matches up, and our y-intercept we said was at positive 2. That matches up as well. All right, you guys got any questions on the intercepts? All right, so let's talk about domain of functions. Okay, so when we divide numbers, let's see, we can't divide by what? So let's say I wanted to do 1 divided by something. What couldn't go right here? 0. You can't divide by 0. That gives you an undefined value. We don't know. A lot of ways one way I like to think about it is like, say you had $10, you divided it by 10 people. How much money would each person get? $1. If I had $25, 25 people in this class, everybody would get $1, right? If I had $0 and I divided it by everybody in here, how much money does each person get? Everybody gets 0. Congratulations. I just gave you 20. I just split my $0 into 25 people. Okay. Now if you flip it, and I have $25, and I try to split it with 0 people,
So you get 25?
who would get 25?
You? Nobody.
No one. So what happens? I burn it and it disappears? Technically, I would go to jail. Not supposed to do that. Like, the money just can't disappear, so we don't know how to divide that. Even if this was like 0.0001, we could split that up with that many, like, with that small of a number. We just can't do 0 because, like, I have no idea what that will be. I don't know what to do with $25. So that's why you can't divide by 0, right? That's one of the cases we will have to look out for. So if we had something like 2 over x, well, x can't be 0. So when we talked about domain the other day, my domain normally would be maybe all real numbers, so from negative infinity to positive infinity, and we use the parentheses. Does that make sense? But when we get these situations and we say, well, wait, x cannot equal 0, I have to split up my domain. So right in between these two numbers somewhere is 0, and I have to take that out. So what we can do is we would break up our domain. So from negative infinity to 0, this would be okay. 0 isn't included. So I have to break up my interval notation where the 0 is. So right here is where x cannot equal 0. So I have to kind of break my domain up and stop it, and then I pick up on the other side of 0. Does that make sense? Okay?
That's an infinity sign right here.
It's supposed to be, yeah. It's supposed to be. And then we'll have like this little union sign. I don't know if you've seen it, but it's like a little U. And it basically says like these two things are connected together. We had to split it up because of this, but these two things are connected together. Okay, so your domain can end up having several pieces, as we see when we do more of these, but this is kind of what we're looking for. What values of x would cause this to happen? The other case we'll look at is when we have a radical. So let's say we had, and we talked about this briefly, but let's say we have x plus 1. You can't take the square root of what kind of numbers? Negative numbers. Square root of 1 is what? Square root of 0 is? It's 0. Because 0 squared is 0. So we can do that. Square root of negative 1 is? No one knows. Because if I tried to go backwards, what's negative 1 squared?
That's what it is, yeah.
1. What's 1 squared? 1. How could I get negative 1 from some number I squared? It just can't happen. This is with all negative numbers. You can put whatever you want in here. Negative 3 squared is 9. 3 squared is also 9. How could I get negative 9 after I square a number? You just can't do it. Because of that, whenever we take the square root of a negative number, it is also undefined. If you try doing your calculator, you get an error. So, any number that will cause something like this to happen, I would have to take it out. All right, so we're going to look at how you do this formula, but I would just think of numbers. Can x be negative 1 here? X can be negative 1. Now, this could be negative 1, but x can be negative 1. Can x be negative 2?
No.
What is this result right here? I can't do that. So x cannot be negative 2. So when I start thinking about it, x has to be greater than what number?
0?
Negative 1.
Negative 1's okay. Can it be negative 1.5?
No.
It can't. Negative 1 is my stopping point. Can it actually equal negative 1?
Yes, so negative, yeah.
So this would be it. If I talk about my domain, negative 1 is my lower limit. It can be as big as I want it to be. Negative 1 included?
Yes, sir.
So like this is my domain right here. Does that make sense? All right, so we're gonna look at these two cases, how to find them, and how to write your domain based on that. So, it's what we talked about. It says the domain of a function f is the set of real numbers, the largest set of real numbers for which the value f of x is a real number. We have to exclude real numbers that cause division by 0, because we can't divide by 0, and real numbers that result in a square root in an why did I put an? Even root? Yeah, even root. And by that, it's like the fourth root of a number, or the sixth root. Because you can do the cube root of a negative number, you just can't do the even root. So if you want, you can put like square root, because that's the ones you'll commonly see. But the rule is really any even root. You can't do the even root of a negative number, all right? So what we would do in these cases, we'll look at these cases, and we might even need to pull some more problems just so we see some more examples. But what could an x be right here for another example? What could an x be? 2? What is 2 minus 3? Can you divide by negative 1? Why not? You can divide by negative 1. 1 divided by negative 1. You can do that. Well, let me back up one step. Is this a fraction or a radical? It's a fraction. I can't let x be values that will result in me dividing by 0. So basically, what will make this bottom equal 0? 3. Add 3 to both sides. When x equals 3, this denominator will equal 0. Does that make sense? So another way I could say this is x cannot be 3. So if I write my domain, x can be anything else. So I could start from negative infinity. I want to go to positive infinity, but where do I have to stop first?
0.
X can be 0.
3.
X can't be 3. So I have to take that out of my domain. And since it's not included, I would use a parentheses. And I'm out of space, but I'll do a little U to show that these two things are connected. And then I will pick up on the other side of 3. And I can go for as long as my heart desires.
Isn't it if it's not connected, it's the other way? The U?
Yeah, but we won't really use that, yeah. This is like or, and the other way is like, yeah, like and. All right? Okay, let's look at some problems. All right, so as you start to as you start to ask yourself, what's the domain of these functions? You always ask yourself these two questions to start off. Do I have a radical? Do I have a fraction? If the answer is yes to one or both of those, then I'm going to have to figure out what values I need to take out. If it's like this first one and the answer is no, because there is no fraction, there is no square root, so there's nothing that x can't be. Okay, so in this first one, it would be all real numbers. Interval notation would say from negative infinity to what? Positive infinity. If we were talking, we would just say all real numbers. Okay, and this is like the double R, maybe you've seen it before. You can say all real numbers. Interval notation, negative infinity to positive infinity. Because there is no fraction, there is no radical. As we go to B, do we have a radical? Meaning like a square root for B. On B? No, on C we do, but we're doing B. Do we have a fraction?
Yes.
We do. So the denominator can't come out to equal what number? 0. So here's the way you solve. Just think about it. What will make the denominator equal 0? You're going to set the denominator equal to 0, because I want to see what values of x will make that happen. All right, so, and this is what you see over here. Set the bottom equal to 0 to find what x can be. I'll just make another note. Set, I'll say set denom. You can put set bottom if you want. Set denom equal to 0 and solve it. And that's going to tell you what x cannot be. Okay, so I'll take my denominator, x squared minus 2x minus 3, and I will set it equal to 0. And this is going to give me those values that x cannot be. Okay, how many terms? So into the second power, what method am I going to use to solve this?
Factor.
I'm going to factor. In the first spots, what do I need? X times x to give me x squared. Then I look for factors of what number? That give me a result of
-2.
-2. There's only two factors for -3, right? 1 times what?
3.
What do the signs need to be to get me -2? Which one needs to be negative? Is my result negative? So the bigger number needs to be negative. Yep. +1. Everybody okay with how we got there? And now I set each factor equal to what? 0, and I get my answers. And honestly, at this point, you could just write x equals -1, x equals 3. But I do want to make sure everybody understands what we're doing. So, this is my first factor. Subtract 1 from each side, x equals -1. This is my second factor. Set it equal to 0. Add 3 to each side this time, and I get x equals 3. So these are the two values that x cannot be. So just to remind myself that I'm not getting a solution, I'm talking about my domain, I like to just throw this in there, so then I remember, oh, x cannot be -1, x cannot be 3. Because if I go back, and if I took the time to work all of this out, let's just use -1 for an example. -1 squared would be 1. -2 times -1 would be what? It would be +2, and I know it's tough because I'm saying it. What's 1 plus 2? What's 3 minus 3? Can't have that. If I put 3 in there, the same thing would happen. 3 squared is 9. -2 times 3 is -6. This is 3 minus 3 is what? Can't have either one of those numbers because that's what happens. Does that make sense? So I would take those two numbers out of my domain. And let me see, I'm going to write this out. I'm going to write it out under here. So if we were writing our domain, just so you see how it looks, I always am hopeful that I can go from -infinity to +infinity. But anything that breaks it up, you just break up that relationship. So from the left, I come from -infinity. What's going to stop me first? -1, because it's to the left of 3. So -1 is going to stop me first. And then I'll pick up on the other side of -1. Notice I use parentheses because -1 isn't included. And then I'll keep going until I get to what number?
3.
Yep, 3. I pick up on the other side of 3, and now I can go to +infinity. Good job. So this is what your domain would look like. Just so we understand it, we had to break it up at these values. And you wouldn't write this in your domain. You wouldn't add this. But I'm just showing you, trying to connect the dots. Does that make sense? All right, so like I say, I'm always hopeful that I can just go from -infinity all the way to +infinity, but when I got to break it up, I break it up. So So when you have a fraction, you set what equal to 0 and solve. Set the bottom equal to 0, solve it. Let's look at what you do when you have a radical like you do on C. Anybody got any questions? All right. So let's finish this, and we're getting close to wrapping up. Okay, so like I said, when you get these functions, you ask yourself, do I have a fraction? For this one, no. So I don't have to worry about the bottom of anything. Do I have a square root? Yes. So whenever you have a square root, you're going to take what's under the radical, and you're going to set it greater than or equal to 0. Now, you can set it equal to 0, but it's going to be a lot of numbers potentially that can't go in that radical. So instead of trying to find every one of those, instead of using an equal sign, you just use inequality, and it's going to take out a whole range of values, and it just makes your life easier. So we take what's under here, and just so we got the little note, we're going to, let's see, take inside of, I'll say root, and set greater than or equal to 0. What kind of numbers would be less than 0? Negative. So this is basically saying what numbers will make this true. Because if you get any number less than 0, it's going to be negative, and you can't take the square root of that. Write more words if you need to. I just try to make it short and efficient. All right, so let's take what's under there, 3x plus 12, and we're going to make it greater than or equal to 0. And then we're going to solve. What would you do first?
Subtract 12 from both sides.
Sounds great to me. 3x is greater than or equal to what?
Negative 12.
Then you would divide both sides by just 3. And my answer is x is greater than -4. Right? So as we finish getting that, let's just check some of these real quick and make sense of it. Can x be -4? According to this, it can. Let's go over and actually see if that's true. What would 3 times -4 be? What's -12 plus 12? Can I do the square root of 0?
Yes.
That's okay. Give me another number in this that satisfies this inequality. What about 0? And I'm just thinking numbers that we can do simple math on. Can x be 0?
Yes.
Because 0 is greater than or equal to -4. 3 times 0 is 0 plus 12. Can I do the square root of just 12? Yeah, so that will work. Give me a number that doesn't satisfy this inequality. -5. X shouldn't be able to be -5. What's 3 times -5? What's -15 plus 12? Can you do the square root of -3? You can't. So that's why these values have to be taken out. So does that make sense? All right, so let's write our domain. Can I go all the way to -infinity this time? What's my lower limit? -4 is as low as I can go, so that's where I'm going to start. Is that included? Yep, because it's equal to. It can be -4. And then I can go up as far as I want. So the upper limit would be positive infinity. All right, everybody okay with that? So those are the two things you have to watch out for. Now, I'll tell you, you can have a combination of the two things. Don't freak out or say oh, we didn't do this, or oh, I don't know what to do. Just do both of them. And just for an example, because I don't want you to freak out when you start doing this on the homework. If you had, just a very basic one. Do I have a radical?
Yes.
Do I have a fraction?
Yes.
So I need to do both things. Because there's multiple things that can stop this from working. What can x be? 0. To find the denominator part, I set the bottom equal to 0. I divide by 2. X cannot equal 0. And what I like to do when it's multiple things, I just kind of make a little list to the side. So when I go to write my domain, I can just put all those breakups in. Okay, so this is one thing I need to take out of my domain. Then I go to the radical, and I set what's under the radical equal to what? Or greater than what? Sorry, that was a bad question. I take what's inside, and I make it greater than or equal to 0, right? I subtract 1 from each side. This is my result. So now together, I need to take both of these things out of my domain. X has to be greater than or equal to -1. Now sometimes this number will be like not in this solution and you don't have to worry about it. With this -1, 0 is greater than or equal to -1. So I'm actually going to need to break this up. What is the smallest number I can have in my domain? What's my lower limit? -1. So that's where I start. Is -1 included? It is. You can, if you don't know, just put it in there and check. If x was -1, -1 plus 1 is 0. I can do the square root of 0. So -1 is actually in there. What am I going to meet next? This 0. So I break it up. Is there anything else stopping me from going to infinity? No, I've got this, I've got this. So now I go to positive infinity. And that would be my domain. So the fraction and the radical, don't freak out. You just do both things. And like I said, you might make a list. I might put all of these things. Even if it was 2 numbers, x can't be -3. I'll make a little list. When I get ready to write my domain, I'll break it up at each one of the things that I have. Right? Feel okay about that? All right. So let's analyze this graph real quick to wrap up. All right. So we got this graph that I sketched over so you can see a little bit better. And we just want to run through and answer all these questions. Shouldn't take too long. Just want to make sure we understand what we're all looking for on some of these. So for part A, we want to do f of 2. What is f of 2? Based on what you see. What variable does 2 represent? The x or the y? The x. So when x is 2, what's y? 5. 5 is my answer. Because when x is 2, my graph is up here at 5. Y is 5. What about f of 5? Of -5, sorry. -3. Is -3 in my domain though? Sorry, in my range?
No.
Does my graph exist here?
No.
So it's undefined at this value because it's an open circle. Just watch out for those kind of things. So here I would write undefined. And even when you start doing these online and you start trying to make your domains, you can click undefined. You just click the box undefined, and that's how you would answer these. All right. So it looks like we're going backwards. Find all of x for which f of x comes out to equal 0. So what is equaling 0? X or y? Y. So when y is 0, where is y 0? Yeah, the x-axis. So at -4 and at 4 would be my answer. Right? Find all of x for which f of x is +3. So when y is 3, what is x, or is there more than one x?
Negative 3, 2, and 3.
When y is 3, so
1, 0, -1, -2, -3.
yeah, so we got like a little range of values, don't we? Because here is where y is 3, and honestly, it can be any of these x values. It could be this one as well, right? So it might make more sense, because technically it could be like 1/2 or 1/3 or 1.1, maybe like 0.1. So I would probably use this as like write like a range of values for this. And then I would add in this one, and we would just approximate it. So I would probably say from -3 until we get to what number? Well, it does kind of stop up in here.
1 and then
So I would go from -3 to 1. And then we got one specific point. Just for argument purpose, let's put like 3.6. And I asked this question just so we can think about it. You won't get a question like this when you start answering stuff. So it won't be this unclear or this kind of foggy. I just asked you this so we can like think about it. Right? Do we have any x-intercepts? Where at?
-4 and 4.
-4 and 4. What about y-intercept?
3.
Yep, when y equals 3. Right, domain of f. The domain. What values are the domain? The x values. What will my lower limit be? What's happening as we go to the left?
-5.
-5. Sounds good. Is that included?
No.
It is not, so I use a parentheses. What's happening as I go to the right? It keeps going which way? Down? Can you go down and right? Or do you just, well, let me ask it differently. We're talking left to right for the domain, so this arrow, is it going right, or would I say it's going down?
It's going right.
It's going right, because I'm talking about the domain. I don't care it's going down.
Left, right, yeah.
I'm talking left to right. So don't fall for that trap and say negative infinity, because these x values are getting bigger. Next will be 7, 8, 9, 10, 11, 12, 100. The x value is getting bigger. So don't fall for that trap. So it's going towards positive infinity as it goes right. Does it make sense why we didn't choose negative infinity? Don't fall for that trap. All right, and then kind of turn your brain and we think about the range. Range is up and down. The lower limit is down, the down part. How far down will my graph end up going?
-3.
Yeah, it's going to keep going down until I can't draw it anymore. So my lower limit is negative infinity. How high up does my graph go? Up here to 5. Is 5 included?
Yes.
It is, because my graph exists right here. Yep.